What's up, you guys? Colin and Pavel here. We are super excited to be talking about APIs and big tech.
Yes, APIs.
Yeah, I'm really excited about this. Pavel, why don't you start off by talking to us about why we have APIs and maybe how they communicate?
That's a very good question. Computers talk to each other constantly. And without APIs, they wouldn't be actually able to communicate. They would talk to each other, but they wouldn't be able to communicate. We need APIs to have a way to describe how computers talk to each other. What is the communication protocol? What kind of information it exchanges, both computers, and what kind of operations can be performed through the API. So let's start with that. APIs are everywhere. If you think about it, literally everywhere. We are using one platform to have a video call. It's possible thanks to APIs. When you go to a kiosk in your McDonald's and you order your favorite sandwich, it uses APIs to transfer your order to the kitchen, and they can start preparing your order. You're using APIs to pay for your order, and this is a different kind of APIs. But still, this has to be somehow described how two machines over internet or any network communicate with each other. That's why we need APIs. So the APIs are the formal standard for communication between a client and an application, which is a server.
Awesome. That's what I thought.
I assure you would. How many APIs have you built so far?
Oh man, I've lost count. Yeah, I've got a little. It's kind of an addiction, really. I built a lot of APIs. I ordered a lot from McDonald's in my day. So, so can you give me some more examples of maybe an API that you've built?
Sure. I actually, throughout my career, I've built several APIs, probably more than several. One of the latest I've built, I have an application. It's an application for developers for testing APIs. So in this application, I store user data, but so far I was storing them locally. So you were only able to access those data, the user data, the data that user provided in the user interface. I was storing this data locally, meaning on your machine. So if you would like to use the same application in another machine, it wouldn't be possible because the data is on your computer. So I've created an API so I can transfer the data stored on the local machine, on my local application, to the cloud, to the server, to the data store. So to do that, I needed an API. So the user can log in on another machine and download this data, so they can have the consistent data between two instances, two machines. So when you create the data in one machine, it instantly is available in another machine. So to do that, I started with describing the data. What kind of data I have in this application? What is the shape of this data, meaning the schema? And after having defined each piece of information I am storing in my application, I started adding behaviors on top of this data. So I started describing how this data behave in my API. So in one instance, one data can be created in my API. In another instance, for another operation, the data can be read from the endpoint. Another instance, it can be deleted or updated or listed as a number of resources. So after having these two defined, I've created an API specification. An API specification, I used RAML, but there is another well-known and commonly used standard, which is Open API Specification, OS. I used one of those two standards to describe my API, essentially to create a blueprint for my API. So this is where I defined my data in this blueprint, and I defined those behaviors, which is operations. And I added endpoints, which is the address, the URL, the address where this data can be read from or updated, and so on and so on. And having this specification, I finally implemented my API. So I started with data definition, then how the data behaves in my API. I created a formal standard, which is the API specification, and then I used it to implement my API. So pretty much that's it. Then I deployed it into the cloud, and my application is now running over internet. It's that easy.
It's that easy. So how many?
I am obviously ignoring, I don't know, say 6-7 weeks of development of this API. But yeah, it was that easy.
Is that the typical life cycle for that type of API?
I'm assuming you're talking about the length of the process.
Yeah.
Wow, this is a very hard question. It depends on the API. If you have a simple to-do list application, probably you can define an API within a day and implement it the next day. But if you have a healthcare system, patient API, whatever, that would probably take months just to design it, not even implement it. So it all depends.
Okay. When you're adding behaviors, what are, it's all CRUD, right? Create, read, update, and delete, right? So, I mean,
So before you go with your question, there are actually different types of APIs. So you have a REST API, which is what you described. REST is a typical CRUD kind of API, create, read, delete, update. But you may have different kinds of API. You may have RPC API. RPC stands for Remote Procedure Call, which is an API, but it doesn't follow the REST architecture. So there is no, it might be, but there is no standard read, create, update, and delete operations. But you have an operation that can do whatever you want. It might be turn off the light, for example. It's really not CRUD operation, because you are not creating anything, you're just signaling something. That's a typical use for RPC. And then you have graph APIs, which is completely different story. When you federate multiple APIs under one endpoint, and you define dynamic query when you can query multiple APIs. So when you are talking about CRUD operations, so let's be very specific, we are talking about REST APIs.
Got it. Okay. So when you're developing these REST APIs and you're adding all these different behaviors, is there anything in particular that you have to keep in mind? Is there anything that you're, more concerned about to, just to, I don't know, keep track of things, or just to, properly create this application? Like,
well, again, the answer is going to be it depends. So you start with your business case, what your API should do. So depending on what your API is and do, meaning what kind of data it holds and what it does with the data, then you're gonna have different things to take care of. So you're gonna start thinking whether there is a user in your API, meaning whether there is authentication, meaning confirming the identity of the user, and then authorization, meaning checking whether this particular user has access to this data. So, for example, if you have a email client over the web, so you can't access someone else's emails, so you have to check whether this person is authorized to read those data. So, depending of what your API actually does, you have to take care of different things like authentication, or whether your API conforms with local laws or state laws. Like, I don't know, if you are handling patient data, as I mentioned before, the healthcare system, you're gonna have to have different requirements of how the data can be transformed, operated on, and how they can be used. It's highly regulated. So depending on your API, you have different requirements.
Gotcha. Why should we design APIs? We're designing.
So I mentioned that I design APIs. Historically, a lot of developers would start developing an API with, well, coding the API. The problem with this approach is you have an idea of an API. You can even like create a bullet points on your notepad of what your API is doing. But while you're coding it, you start encountering issues with your API, like, oh, this operation shouldn't be returning this kind of data. It should return different kind of data, or maybe the data should have different schema. So maybe you should add some fields, some properties to the response, or maybe you should remove some fields that are just technical data that is not really used by your application, and so on. And changing an API that is already written is much, much more expensive than working with API specification. So all of these issues you can solve by creating a blueprint for your API. Just like any other engineer creates a blueprint, whether it's a civil engineer or an engineer creating an engine for Formula One, they would start with a blueprint. They design every aspect of the thing that they are creating, and then they actually go into the production. So the same goes for APIs. You would create the API specification so you can have blueprints, so you can define the data, then define the operations and endpoints and security constraints and all of it in one blueprint. So you can easily see where are the issues with your application. So you can take the business requirements and you translate it into a blueprint.
Are there ever times when it's beneficial to just build something really quick and skip the blueprint process, maybe to just get something out there and get an idea, like a proof of concept almost? Or is it like that's just super frowned upon at the big tech level? I would imagine,
in the big tech level, if you're an enterprise developer, you shouldn't be doing this. You really shouldn't be doing this. That's not very professional. You should always start with a blueprint, because in the long run, it will save you a lot of time. That said, I was hot-headed developer before, and I would jump into coding like right away. I had an idea. Oh, I'm gonna code an API, and always, every single time when I did this, and I did this a couple of times in my life, every single time I would actually end up rewriting the whole thing again and again, because it wouldn't, in the end, fit my business requirements of my application. So I had some imagination how my application is gonna look like, gonna work like, and so on, so on. So I started with the backend. I created the backend so I can work on the front end. And after creating the backend, I realized that, oh, I made so many mistakes while developing this API. No, I had to go back, recreate the whole thing, because my UI actually needed some different kind of data or different ways of querying for the data, and so on, so on. So it's much, much easier for me when I started designing API first.
Okay. Well, obviously, kind of like with anything, you don't want to spend too much time on any one thing, right? You can't make anything perfect, right? So how much
Yeah.
time should someone, I mean, how much time are you typically spending in the design phase?
Well, that's a very hard question, and again, it's gonna depend on what your business needs are. If you are creating a to-do app, you're probably gonna spend 2-3 hours designing the application. The API I created for my application to transfer data from locally stored user data to cloud, it took me, if I remember correctly, it took me about 3 weeks to properly design it.
Hmm.
So it all depends because you have to describe the data, but then you also have to think about how to secure the data, how to consistently create these interfaces, API, application programming interface, how to consistently create these interfaces the API is using to communicate with the server. So I needed an extra time to make sure that the API will do what I want it to do.
Focusing now on documentation for an API, are you, while you're designing, is it at every stage you're also documenting the API, or are you just doing that at the very end? Talk to us a little bit about documentation in general for an API, and then
Okay.
yeah.
So documentation is very important part of creating an API, and um, there are programs that allow you to create API specification and automatically transform it into API documentation. I actually authored a tool that does this automatically. So it takes the sources of your API specification of the blueprint, and it reads those sources and translates it into a meaningful documentation, where it renders you the endpoint, operations under this endpoint, like get, delete, update, and the schemas and all the parameters that are required or optional for this specific operation. So I have built a tool like this. So there are tools that allows you to transfer your raw specification files into a meaningful documentation. And you can use this documentation to share your API specification. You can share as an architect, for example, you can share if you are an architect creating an API specification and you're sharing it with the development team that implements this API, you would share this documentation, link to this documentation, so they can see how this API should behave like, work like.
Before we go into the next part, I do have one other question. Are a lot of people newer developers, are they good at writing documentation? Is there a skill? Is there a real art to documentation? Because I feel like there is, especially after, you know, us going through that eBay documentation a little while back.
Oh yeah.
For context, Papa was helping me with a project, and we had to go through eBay's API process. Go through their documentation, and it was confusing, right? Like there were elements of it that weren't clear.
It was.
I still have nightmares.
It was confusing in few places. I work with APIs every single day. I read documentation for APIs every single day, and eBay's documentation was very confusing. So I don't know if you remember this particular part when I was trying to figure out the authorization, how to authenticate the user.
Yeah.
They had like 2 different ways.
Yeah,
but
the
for
OAuth and the auth and auth.
Auth and auth, which is completely like custom thing. Auth is a standard, and auth and auth is whatever eBay have developed. Anyway, the point is, it took me a long time to understand what is the difference between the two. And I actually, I don't know if you remember, I actually told you to use out and out at first, and you actually were trying to make those requests without an out. And then it turns out that this particular endpoint that you wanted to query was actually using of, which is completely different implementation. And the whole code that you actually wrote was a trash, and we had to start over. So yeah, documentation is very important. And they're usually in big companies, they're usually a unit of UX writers who are writers, but understanding the technological side, so they can talk to a developer who actually implemented the API, talk to the developer, and write a meaningful and easy to consume documentation for an API.
Oh, it's the UX. Did you say it was a UX designer?
Writer.
Does this? Writer?
UX writer. So companies have, big tech companies have UX writers. Well, at least I hope so, that they all have it. My company have it. I know a couple of big tech companies that have UX writers. So these are UXers who specialize in writing documentation for the end user. So they describe, they translate the internal jargon into a meaningful documentation for the consumer that doesn't understand the context, company's context.
Got it. Okay, that answers some of those questions. I think we should move on. I want to ask about APIs at like an enterprise environment, and talk about some of the steps that one takes in a company to go from, starting from start to finish.
Okay, so there are a few steps that you take to create an API product, API application. So in short, it's the definition, the specification, the development, testing, deployment, documentation, and productization. So that's, in short, is the ideal API lifecycle. So you start with the definition. So you have to know what the API is. So you write like a business cases, what the API is doing. Now, in my case, for my API, my business case was to synchronize data that I was storing in my application in the cloud, so it can be synchronized between different instances the user is using. So you can use it on your desktop, on your laptop, and so on, so on. So that was my primary business case. So I defined my API as a synchronization service for user data. That's a very valid use case. Then the next ideal step is the design part. When you define the blueprint for your API, you are not coding just yet. You are defining each endpoint, each operation, each schema, the response for each state. So whether it's a 200 response, which is success, and it returns the data that you expected, or maybe it's 401, which is unauthorized. So you have to define those different responses and different inputs to your API before you get into the development phase. So once you have the requirements and the blueprints, then you can send it to the development team to code the API. So they code the API, and after that, there is the next stage, which is the testing phase, like with any other software. So developers who wrote the code for the API write the tests for this API. This usually takes even longer than writing the code itself, because you have to consider so many more cases, like not only the success story, the success of your API, the calling the function of the API, but also what happens when it goes wrong. Whether your API is still going to work, whether it's return the right response, meaning error response, and so on, so on. So testing is very important. Then you have the deployment phase. So some companies can do this manually. So you as a developer, you test your API and you just click deploy, and it actually creates an instance of your API and your API is instantly available for consumers to use. But the more enterprise approach would suggest you to use CI/CD. CI/CD is a continuous integration or continuous delivery, where, for example, you would push your code to GitHub, and you would run GitHub actions that actually perform the same tests, but in the different environment. So it's not your local machine that may have some difference in environment. You recreate this in the staging environment in CD, continuous delivery, and the tests are running. And after those tests finish with success, then your CD deploys your application to the cloud. So that is done. So it's so you can be sure that the API you are writing is stable and can be deployed to the cloud. So after you deploy your API to the cloud, you go to another stage, which is documenting your API. In most cases, you can use the blueprints that you have defined to auto-generate the documentation. But sometimes you may need to create a custom documentation, like just to explain in details how authorization works, or how, like, some specific use case of your API that is very hard to explain just by writing a documentation. That's where you would ask a UX writer to write those documentations. And you publish this documentation as an API portal, so others can consume your API, can discover your API, meaning find your API in some API catalog or whatever, can learn your API, so understand what the API does, and consume the API by making test requests to usually mocking service or a testing environment, something like that. And the last stage is productization of your API. Your API is essentially a digital product. You deploy it as a running application, and people can use it. So you can actually treat it as a product. So you have to take care of proper discovery of this application, whether it's discoverable through search engine, through API catalogs, whether it's properly documented, or even if your platform that you are deploying an API allows it, whether you properly monetize your API, which is also an option in many API platforms.
Got it.
If that makes sense.
I think that makes sense. I think we're kind of towards the end here.
Yeah, it's time for you. It's time for you to build an API.
It's time for me to build an API. I've got a lot of ideas.
Or maybe you can just finish the implementation of the your eBay eBay application, because no. I don't know if you finished this one.
No, I didn't. I need help. I need help from Big Tech. So I want to thank everybody for watching and listening. Pavel and I are really happy that you clicked and listened. Pavel, if you have anything else you wanted to add at the end, let us know.
Oh yeah, of course. If you have any questions, leave the comment below. Let us know if there is any particular topic you would like to hear, and we will be happy to talk about it.
Yes, because that's what we're doing. And stay tuned. All right. Thank you guys so much, and we will see you next time.